Okay, so we're going to round out this conversation by talking about trends in periodic properties. Trends in periodic properties. And in order to appreciate that, we're going to first of all consider what does the electronic configuration of an atom say about that atom. Okay? So first of all, we're going to differentiate between valence electrons and core electrons. So valence electrons are the electrons in the outer shell. They're the ones in the outer shell. So if one atom comes up to another one, it's the electrons in the outer shell that the atoms see, right? So what does B see here? What does B see here? If atom A has got 2 electrons in its outer shell, it's got its inner shell here, and its outer shell's got 2 electrons. B sees the 2 electrons, and that's why elements in groups act like each other, because they have similar valence configurations. All right. So the group number tells how many valence electrons or how many electrons are in the outer shell. We've seen that a couple times. Perhaps now it's becoming a little more obvious. So let's come here and look at the valence electron configuration for each of these atoms. So hydrogen, it doesn't have any inner electrons. It only has 1 electron, and it's in its outer shell, and so its valence electron configuration is 1s1. Lithium, right? Its full electronic configuration goes helium and then 2s1, right? But can you see how lithium looks on the outside kind of like helium, right? And sodium's outermost electron is 3s1, and it looks kind of like 2s1, which looks kind of like 1s1, right? And here's potassium, 4s1. So here, another example, nitrogen, the outermost electrons are in the 2 shell, and they look like 2s2, 2p3. And phosphorus look like 3s2, 3p3, right? And so you can see why phosphorus and nitrogen have similar chemistries. All right, so using the periodic table, write the group number and the period and the valence electron configuration for the following. Just the valence electron configuration, right? Pause the video and then come back and check your answers against mine. Okay. Whoops, whoa, lost that. So, come here, come here, come here. All right, so here's our periodic table. And calcium was the first one, and I can see it's in the 4th period. It's in the S block of the 4th period, so it's going to end with 4s2, right? 4s2. So calcium is going to be, its valence is 4s2. The group number is 2, group 2. Group 2, and the period is 4, right? And so it's going to be 4s2. All right, and then lead is over here. We'll switch colors for lead. Come over here. Lead is down here. Can you see that's in the P block, right? It's in the P block, and it is, it's in the P block, and it's, just a second here, it's in the 2nd column of the P block, right? So, and it looks like it's the 1, 2, 3, 4, 5, 6 period, so it's going to be 6p2. Its group is 1, 2, 3, 4. It's in group 4. It's group 4. And its period is 6. And its valence electron configuration is going to be 6, S2, 6p2. All right, so those are the valence electron configurations for calcium and lead. Okay, now that we know that, we're going to actually symbolize these valence electrons by using something called Lewis symbols. Lewis symbols represent the valence electrons as dots placed on the outside, like I did in a previous conversation, or a previous slide up here with A and B, right? So what we do is we put all of the dots on the outside of the symbol for an element, and we only show the valence electrons. We don't show the innermost electrons. All right. So for magnesium, it's in group 2, so it only has 2 valence electrons, we would go 1, 2, or we could say 1, 2, or we could say 1, 2, right? Or we could say 1, 2, right? We put 2 electrons outside it. We don't pair them like I did in that previous one with A. We don't pair them until we get 5 or more. All right, so we'll do some more Lewis symbols here. The Lewis symbol for hydrogen is just 1 electron on the outside. It doesn't matter if it's on that side or this side or on the top or bottom. It doesn't matter. Lithium is also 1 electron. That's the valence electron. And again, just like we were showing the valence electron configurations, you can see why they have similar chemistries, right? Because they each have 1 electron in their outer shell. And beryllium and magnesium both have 2 electrons in their outer shell. Carbon has 4 electrons in its outer shell, and so does silicon. That's kind of cool, isn't it? Germanium also does, right? But once we have a 5th electron in the outer shell, we start pairing them. And so nitrogen, can you see that? There's 2 that are paired right there. And oxygen has 6 in its outer shell, so we pair 2, right? So here's how I would do oxygen. I would go 1, 2, 3, 4, 5, 6. Okay? So those are the Lewis symbols for the atoms up through krypton. Okay, so as a learning check, pause the video, look at your periodic table, and write the electron dot symbol for each of the following elements. Okay, I'm going to suppose you did that. And first of all, I'm going to start with chlorine. Chlorine's in group 7. Watch this. 1, 2, 3, 4, 5, 6, 7. So chlorine's got 7 electrons. I'm going to go 1, 2, 3, 4, 5, 6, 7. Okay, so that's the Lewis symbol for chlorine. Carbon is in group 4, right? 1, 2, 3, 4. So carbon's got 4. 1, 2, 3, 4, right? We'll make my dots a little bit bigger. And let's go with nitrogen then is in group 7, no, 5. 1, 2, 3, 4, 5. Nitrogen group 5. So we go 1, 2, 3, 4, 5. All right, and those are the electron dot symbols for each of the following elements. In our next conversation, we'll talk about what implications these structures have on their properties.